All right, welcome back. Let's talk about data models. We're going to talk about data models. Okay, let's go. Let's get into this. So when we think about data models, what is a model? Well, I'd say, I think it's pretty easy to understand that. A model is a representation of something else, something smaller. Like a model car is a representation of typically a real car, something else. I'd say simple representations of complex real world data structures. And it helps us to be able to understand and visualize things, real world things in a much smaller environment, to where we can actually see it many times in a 360-degree view. So when I think about models, this is just something personal. This is a little extra here, right? I build things 3 times, okay? We do a conceptual model, what I call a vision, where you see it in your mind. And then there's a logical model. That's when you write it down. And then the physical model is when you actually build it. So many times, where we go wrong is we jump right into the physical. Let's get the tool bags and let's start sawing and cutting wood, and we really haven't had a good vision, and we didn't write the vision down. So when we think about data models, it's the same thing. The whole purpose of these models is so that we can see it conceptually, we can see it logically, and we can see it physically. Some components of a model, entity. We've talked about this in the last lesson. Actually, anything in which data can be collected about. The attribute, that's a characteristic of that entity. A constraint. This one we did not. What is a constraint? A restriction placed on the data. Many things have constraints that, we don't want this to do this, or there are certain limitations. And relationships, okay? When we think about relationships, 3 types of relationships that we typically talk about with respect to entities. So these are associations between entities. We can have a one-to-one, one-to-many, and a many-to-many. This is how I try to explain this. I love analogies, and this is the analogy that I use. Okay, what I call keeping relationships simple. Sounds like a marriage counseling, doesn't it? Well, funny you say that, because this is all based on just that. When we think about a one-to-one relationship, yes, one husband's relationship with one wife. Yes, the way that it was created, the way that it was designed to be done, a one-to-one. All right, now what about one-to-many? Well, you think about this. One mother can have relationship with many children. One mother, many children. One-to-many. You could have many-to-many. This would be like our siblings. You get your siblings' relationship with all other siblings. So, you and all your brothers and sisters, you have many, and many, they all have relationships. One-to-one, husband and wife. One-to-many, one parent could have a relationship with many children. And siblings, you have many siblings, can have many relationships with other siblings. Keep it simple. That's all relationship, this relationship model is. Now, when we think about this from now, let's move into something probably a little more database aligned. When we think about this entity relationship, this is a way that now within the world of data structures, we start to show entity relationships. The ER model is what this is called. Different ways of notating this. You can use the chin notation or the crow's foot notation. So if we look at what we got up here at the top, right? This is a one-to-many relationship. You can have one painter who can paint many paintings. Okay? So you see that relationship. Now, in the crow's foot notation, this is what it would look like. We have one painter, all right? And that one painter could have, and that's what the crow's foot is showing, a mini relationship with the paintings. Now you see that the twos and the ones, I'm not going to get into those for this class, for this teaching right now. But with respect to the ordinal relationship, unary, binary relationships. Now this is a look at a many to many. You could have many employees can learn any number of skills, many skills. So a many to many relationship. This is what it would look like in the crow's foot notation. Like I say, employees learning many skills. And a one-to-one. You have employee manages, one employee will manage one store. One-to-one relationship. But this is the entity relationship model. Like I say, it's just a way of mapping relationships. So now we kind of understand that. Now we can actually start looking at how now these relationships can be translated into excuse me, some type of database using rational keys. Okay, well, a rational key, so every row in a table must be uniquely identifiable by some type of key. All right, and there are multiple types of keys. Don't let them confuse you. It's not that difficult, really, is it? You got super keys, candidate keys, primary, alternate, and foreign keys. So what is super keys? A super key is a group of single or multiple keys that identify rows in a table. That's all it is. It could be many types of super keys. As a matter of fact, let me click on this. This hopefully may help explain this a little better as I go. So a super keys, could be primary, could be a candidate keys, alternate keys. All of those are considered to be super keys. A candidate key, like I say, that's a set of attributes that uniquely identify tuples, or a tuple being just one of these little cells. Like if you work in Excel, you call it a cell database. They call them tuples. Okay, in a table, a candidate key is a super key, which is not with no repeated attributes, and the primary key should be selected from the candidate keys. So now you look at our diagram down here. Any of these are candidate keys, meaning that they are super keys. Nothing is repeated, right? There's no repeated attributes. Your employee ID, employee name, whether it's your employee license, employee passport, all of those, and they're all candidate keys because any of these could be a primary key. So what is a primary key? That's a column or a group of columns in a table that uniquely identify every row in that table. So for this example I'm going to use this employee ID as the candidate key. So every row, 1001, 1002, 1003, are uniquely identified. That employee ID is a unique identifier that will identify each of these rows. Alternate key. Like I said, all the keys which are not primary keys are called alternate keys. That's all they are, right? Nothing fancy there. And our foreign key. Now the foreign keys are very important. Why? Because that's how you create relationships with other tables. So like I said, this was table 1, and I'm taking this this ID number, and when I go to table 2, I'm going to put the exact same column or a set of rows in table 2. So now there's a relationship between this DID number between table 1 and table 2. So now I have a foreign key that has a relationship with table 2, a row in table 2. So you see, when you think about the keys, that's really all they are. Any of these can be super keys, your primary, your candidate, alternate keys. When we think about candidate keys, these are a set of keys that, let's say, have attributes that can uniquely identify someone in a table. Now, from those candidate keys, we're going to select our primary key. And again, the primary key, that is the one that we will actually use, of the candidates to actually be able to uniquely identify everyone in that table. Anything difficult there? Nah, not at all. Let's take a look at this from this perspective. All right, this is just an example, very simple example, okay? So this is a school, a database we want to build for a school, where we have students, we have faculty, we have staff, we've got class data, and we've got family information. All the things a school would typically collect, right? So we have a table, and we're going to collect all these in tables. We have a table for family data, we have a table for student data, and we have a table for grade data. Like I say, so within the family table, data table, we've got the family ID number. Here again, it's a number we could make up for each family. The parent's name, the parent's phone number, and the email. Student data, we're going to collect the student ID number, their first name, last name, the family ID, class, the subject that they're going to take. And then grade data is over here. So in our grade data, we got an assessment ID, the student ID, the class ID, and the grade. So now all those things are relationable. Now we can build relationships. So let's take a look at the staff. Now we're also in the same database, relational database. We want to keep information about the staff and what they're doing. So we got a table that has a staff data. And we have a staff ID number, their first name, last name, and email address. Now we got class data. And now in this class data, we're going to have the class ID, subject, class subject, teacher ID, and class time. So now let's say, okay, I got all these separate tables. How do I want to bring these together? Well, In my family data, I marked my family ID as a primary key. In my student data, the student ID is a primary key, but you see I have a field called family data, family ID, which is a foreign key. In my grade, you can see the relationships I've set up. I make the assessment ID, excuse me, the primary key, the student ID, and the class ID foreign keys. So now I can set up a relationship between my family data table and my student data table based on the primary key of family to the foreign key here. I can also, from the student, set up a relationship between the student data and the grades. So I can go into my database now and I can actually do a query, and if I pull up the family, let's say student's name, Johnny Smith, because I have this relationship, I know that Johnny Smith's parents are Susie Smith and Donald Smith, and I know their email addresses. Why? Because it's able to link, it's able to pull that data from this table, the query. I also know that Johnny Smith is, based on his student ID, now I can pull what class he's in and what grade he's having in that class. So now the bottom row, I'm going to make a relationship between the staff data, the staff ID number, which is the same as the teacher ID number. Okay? In the class, I use teacher ID. In the staff, I use staff ID. However, they're the same. The data in there is the same, so I can still make that relationship. So now, and again, and as a primary, because it's my class ID, so you see now I've linked the class to here. So not only now can I tell you that, who Johnny Smith's parents are, I can tell you what class he's in, and also who is teaching that class, and pull up information about that staff. And if I want to send them an email, I can let them know that Johnny Smith's parents just called, here's their phone number, please email them back. You see now I made a relationship, a relationship between all the entities in all of these tables based on primary keys, based on foreign keys. So now I can do a query using some type of query language that we'll talk about here shortly, like SQL, SQL, so that which is a standard query language. That now I can extract whatever information I want to based on the relationships that have been established. And some of these relationships are one-to-one, some one-to-many. For instance, staff, they're going to have one teacher who has a one-to-many relationship with classes. One teacher can teach multiple classes. So you see how those relationships go. However, one student, would have a different relationship with the parents or the grade. One student should have one grade, one-to-one, for that class. So that's how those relationships, and that's how starts to take effect in this environment. Another way we can look at this is through what we call object-oriented modeling. Okay, and this is a more complex modeling environment. Now, what this looks at, it looks at data relationships in a single structure known as an object. It looks at everything as an object. Now, so what is objects? Objects share similar characteristics, are grouped into classes. Okay, objects that share similar characteristics are grouped into classes. Classes are organized in a class hierarchy, and then within that, there's attributes that describe the property of the object. Let me give you again a very simple example. So if we have circles, shapes, we have circles, rectangles, and triangles are objects in this model. All right, the objects circle, rectangle, and triangle inherit from the object shape. So this is our, we have an object that's shapes. Now within that shape, I want to be able to do what? I want to be able to find the area and the perimeter of each shape. Those are the attributes of each of these. So if I look at a circle, now once I look at the attributes of a circle, to find the area and the perimeter, I have to have the center and the radius. Of a triangle, I have to have the length and the breadth. Of a rectangle, the base and the height. So those are the different attributes associated with each of the objects. These are different classes of objects that have a relationship with shape. So that is how we look at things from an object perspective, okay? And each object has a separate attribute. So now I'm able to, I've put together a relationship between three things that we typically think had no relationship: a circle, a triangle, and a rectangle. However, there is a relationship, and that relationship is the area. How do you find the area of each of those? All right. So that's what object-oriented modeling does for us. Now we can see things from an object perspective, not just from an entity perspective. So when we think about object-oriented modeling, we use what we call a unified modeling language, UML, that describes the diagrams and the different symbols. So when we think about, and what I kind of put together here, this is how you can look at representation from all three methods. We just talked about the entity relationship model. This is what UML would look like, and this is what our object would look like over here, okay? So this is object representation. We have an invoice, and this is and within that invoice, these are the customer and the line number, excuse me, are the classes. And within that, these are the attributes of those. Same thing here, exact same thing. Here's the customer from a UML, and it also tells you what the relationship is, one-to-one or one-to-many. These are the attributes within that database. And if we look at it from a ER, or a entity relationship, customer, again, you see the relationship and how it relates to the line. Just different ways of different types of models that we used to look at. So when we think about data models, let's kind of summarize this thing. It all comes down to what we call semantics. Okay, semantics, that is the branch of linguistics and logic that deals with meaning, that assigns meaning to things. Okay, semantic data is data that has been structured to add meaning to the data. And this is done by doing what we just talked about, creating relationships between these entities. Semantic data helps with the maintenance of the data consistency. So let's take a look at what we mean by that. So semantics in data modeling have increased over the years. Early on, when we had just hierarchical database or network type database where there were really no ad hoc queries, you could just look at records one at a time, there was very little semantics. There was very little meaning that you could grasp and pull from that. And as we went through relational databases and entity relationships, we've added more semantics. And now as we get into really more complex databases, database managed, object-oriented, extended relationship databases, things that we see now with big data and all these, it has added more semantics to, or more meaning, more logic and more meaning to the data, to where now we can do so many more things with it from a behavioral perspective, and improve data exchanges. So as our data sets have gotten larger, our databases and database management systems have become more complex, but at the same time we've also added more meaning to that data and more granularity to how we can extract data and make meaning and make sense out of that. All right, so when we come back, we are going to talk about structured query languages and big data. Okay, see you right back.